Hi, we're going to see how to make an Android app which can be used with LS6. First go to File, New, and then New Project. Write the name of the application, for example EX1. Click on Next. Leave the default settings, go to Next. Take an empty activity and click on Next. Let the defaults be there and click on Finish. Once your app has opened, you can see your source code under Java main activity. That's your source code. To look at your layout, just go on res and then layout and then click on activity underscore main.xml. Once you open your XML file, you will see hello world written here. You can delete the. We're going to go to text inside the design page on the activity main. Let's now create a button. You can find it in the all palette. Create a button below it. Let's call it connect. Go to the text. In the ID of the button, let's call it be connect. We can now put a click on click listener. We can call it be connect click. Let's now go to the main activity.java. Inside your class, let's create a boolean called connected. Inside the onCreate, let's set the connected as false by default. You must have noticed I've copied and pasted few classes, for example the robot.com, TCP client, motor and LED, I2C write. Let's understand what each of these classes do. If we go inside the robot.com, you will see that it basically takes care of interacting with the motors, for example the AX series, or in some of the functions you can even control the GPIO outputs, for example set output, set GPIO. We can also use the motor driver by using the set motor PWM function inside the robot.com class. The TCP client, motor and LED and I2C write are classes which are used by this robot.com class. We will not go into details of that. I have given the links for copying these classes, namely TCP client, robot.com, motor and LED and I2C write. You can simply copy and paste or create new Java classes by clicking here and clicking on new and Java class, and then you can go ahead and copy and paste if you want. Once we are done with this, let's go back to our activity main.xml. You will observe that there are a few red lines. Don't worry, we can get rid of them by simply auto connecting the constraints on the design page. We'll do that once we're done with everything. Let's come back to the main activity.java. As you observed, we created an on-click listener called beConnectClick. So we're simply going to create a function here. Once we're done with this function, you'll observe what we're going to do now is create a button beConnect. It'll throw a red error. Just press Alt Enter. It'll import the Android widget button over here. Once you're done with this, come on the onCreate function and assign the beConnect by using typecast and then find view by id r.id. B connect, you will observe that the B connect is the same as in your activity mail.xml. Similarly, we're also going to create a robot.com robot, and we can initialize it here, robot. You want to go ahead and now make a motor and LED. Just like in robot, we're going to assign motor and LED as new motor and LED. Once you're done with this, what we're going to do is create a B connect click, which was the on click listener for the B connect button. Before going ahead with making the B connect click, we also need to create and edit text. We'll call it etip. Inside the onCreate class, we can also initialize etip as the edit text find view by id. r.id.etip. Once you're done with this, you will observe that if we are connected, then we basically disconnect the TCP client inside the robot, whereas if we are not connected yet, that is connected is false. We're going to change this to boolean.false. If you see, if it's false, it's going to connect it by opening a new TCP, and it's going to get the IP link from your etip. Let's go back to our activity main and then design page. Let's create two buttons. Let's create two buttons. I'm going to place them nearby. Let's call this button as left and this button as right. We're going to go to text. Once we are on the text, let's call this as B left, and let's call this as B right. The same way we created an on-click listener for the B connect, we're going to make an Android on-click listener called as B left click. Similarly, we're going to create another on-click listener, and we're going to call it B right click. I'm going to see red lines because we don't have the listeners. So we're going to go back to our Java class, and let's address our buttons first. So we're going to call it B right, B left, and again we have to find them by ID. So we're going to call it B right equals to button find view by ID r.id.b right. Same way we're going to make a B left and typecast it, and then find view by ID r.id.b left. Once we're done with this, what we're going to do is add a touch down and action down and action up listener for these two buttons. Now if you observe, we've created a set on touch listener. So let's see when the action down, that is when you press down the button for the left, what are we doing here? First of all, we're going to set the background color of B left as some color. On top of that, what we're going to do is use the robot class. So we have a robot object over here, and we assume that we've already connected using the B connect click. So the moment you click on the B connect, and then you have connected to your robot, now you click on the left button, what should happen is we've used this function called right degree sync AXMX. This function can be used to actuate as many motors as you like on the AXMX series, that is Dynamixel 1. The first parameter inside the function is a list of IDs. The second is the list of motor types. The third is the angles that you want to put for each motor. The fourth is at what velocities each motor should operate at. And the last one is a common baud rate for all of these motors. So when we click on left, motor number 1, which is a Dynamixel AX12, is going to go to 135 degrees. Since AX12s have the center as 150, we're going to rotate it in by 15 degrees. Similarly, when we leave the button, it's going to go back to 150 degrees, as you see here. So this is the function that you need to note: robot.write degrees sync AXMX. ID of the motor is 1. It's an AX12. Let's now go to our activity main design. Let's create 2 more buttons. Let's call them for front and back. So we're going to do the same procedure. Go to button, call it front. Go to button, call it back. And just the same way, we come to the text and front, and we'll call this button as B front and this call as B back. Once you're done with this, we go back to our main activity, add the list of buttons as B front, B back, and just the same way, B front equals to button find view by ID r.id dot B front, and B back as button find view by ID r.id dot B back. Alright, now we're done with this. Now let's create an on-touch listener for B front and B back as well. Let's look at the function. You will observe that the action down and action up is the same way we're going to control these buttons as well. The function that we are using here is called robot.setMotorPWM. What it's going to do is it's going to set the PWM according to a speed bar that we'll create now after this, and the motor driver should get a PWM based on the speed bar. Also, the direction will be set using the motor and LED.motor underscore F direction, which means forward, or the back direction, which is B direction, B dir. Let's understand what the parameters are for set motor PWM. The first parameter is the motor and LED. We're assuming that it's owned by the main activity class. So we're going to just pass the entire variable to this function, which is going to go in the robot class eventually. The second parameter is the direction, and the third parameter is the velocity. The velocity can be given from 0 to 100 in terms of percentage. Make sure these are integers. So what does speed bar signify? So we're going to create a seek bar. We're going to call it the speed bar, and we're going to get the progress. We're going to program the seek bar such that the progress comes from 0 to 10. I'm going to multiply into 10 so that it's from 0 to 100 for this particular function. The moment we leave this button, it's going to set the direction as motor stop and velocity as the 0. So when you give a 0 velocity to the motors, it basically stops. So the moment you leave the button, the car stops. So now let's come to activity main design page, and let's add a seek bar. Let's stretch it a little. That's okay. We go to the text. In fact, in the design, you can set the maximum as 10 and the current progress as 5. And we can come to text and over here let's call it speed bar. Let's come back to our main activity.java, create a seek bar called as speed bar, with a capital B. Inside our on create, let's also add our speed bar equals to seek bar find view by id r.id dot speed bar. If you observe now, the error from here is gone. You can even look in the designs. You can expand your speed bar a little using the pointers here and position it. So we're going to get our speed. So a couple of changes we need to make now are, in the seek bar, let's set the style as discrete. This way your seek bar starts looking like this, so you cannot really choose intermediate points, but at the same time the response of the seek bar stops because it's discrete. It does not flush a lot of values to the Wi-Fi, so it's kind of more efficient to use a discrete value instead of a continuous value, in which case you'll keep getting a new callback and then every time you'll keep releasing a new TCP/IP message to your controller. Another thing that you have to take care of is you have to go to your manifests, Android manifest. You have to add a permission for the internet. This allows your app to use the Wi-Fi. Make sure you add this line. Once you're done with this, your app is ready. All you have to do is come to design, clear all constraints, and then use the magic wand. Once you're done with using the magic wand, even if it's blinking, even if it says there's an error, it should be okay because I've tested it, and once you upload it to your phone it will actually work. So let's just click on save and then build the APK. You can locate your APK. So your APK is over here, so just copy and okay, now let's understand our hardware. So we have our LS6 board over here, and we have a Dynamixel AX12 for the steering over here. Along with that we have a couple of bow motors here and a motor driver here. Don't worry about these extra servos over here. So for the wiring of the Dynamixel, it's pretty simple. We have the USB port over here, so looking from that direction, basically it's on the bottom. You will see, we will give the wiring schematic as well. We connect the Dynamixel directly, and from here the other wire is actually going to the other Dynamixels over here, so don't worry about it. So this is the wire to drive the Dynamixels over here, directly going to this motor. The next part that we have to look is at the motor driver. So the motor driver needs power. The power can be taken from over here, and then there are about 4 more wires over here into the motor driver. These wires will be taken and the signals will be provided from 2 points, which will be given in the wiring schematic over here at the bottom. So basically this is pretty much it. Okay, so now let's turn on our LS6 EVK. So I've turned it on already. The Wi-Fi is up. You can go on the Wi-Fi and choose the Sirena, the particular EVK. Once you're connected to it, all you have to do is open your app. So this was our app. So you already have the default IP. You'll just let it be, click on connect, and now just to check, we can reduce the speed a little on the seek bar. over here, and then you click on front, so it works. Similarly, if you want to check the left and right, we can also increase the speed using the seat bar, and you can then disconnect your app and just end it.